In this video, we're going to solve quadratic equations by using our knowledge of square roots.
So if we're going to be solving quadratic equations, we need to know what a quadratic equation actually is. So a quadratic equation is an equation that contains a second degree polynomial. And if you remember back from earlier, we learned about polynomials. And a second degree polynomial is any equation that contains an expression that has an x squared or y squared, z squared, whatever it is. The highest exponent that a variable has is 2. So an example of a second degree polynomial might be something like x squared plus 4, or something like, 3x squared minus 7x plus 8. So those are second degree polynomials, and if we have equations, it means it has some sort of equation with it. So we could have something like, equals 3 or equals 0. So we're going to be focused on solving these types of equations that contain second degree polynomials in this lesson.
So if you look on the screen, you can see that we have two quadratic equations. You can see that x squared is the highest power of x within the equation, and you can see that you have a polynomial because it consists of only variables, numbers, and then the product or sum of variables and numbers. So we can see we have a quadratic here. And hopefully your brain is already thinking, well, hey, I know how to solve these. Most of you are probably saying, well, my first step in the first one would be to add 12 to each side. So I end up with 2x squared plus 11x plus 12, and that's equal to 0. And then I have 4 factoring strategies, and I know that the ABC method for factoring trinomials would be the best fit here. And then if you're looking at the second one, you're probably noticing, well, there's only 2 terms, and they both are divisible by 6, and they both contain an x. So you're probably already thinking, well, I could solve this by using the greatest common factor factoring strategy. And if you're thinking in that direction, that is good. We already have one strategy for solving quadratics, and that's all of our factoring strategies. So all of those still apply and can help us to solve quadratic equations. What we're going to focus on today is we're going to focus on a different type of looking quadratic equation. So notice in these that we always have an x squared or an x term. So we have an x squared and an x term. What we're going to focus on today are the equations that don't have both. So for example, we might have x squared plus 20 is equal to 50. This is a situation where we just have our x squared term. Or we might have something where the x squared term is kind of hidden. We have like x plus 4 quantity squared equals 25. Again, notice that we have this x inside of here. It's ultimately being squared, but it doesn't look like the problems that we saw up here. So today's strategy is meant to help us solve other types of quadratic equations that aren't necessarily factorable. So that's why we're learning the strategy, is it will help us to learn how to solve other types of quadratic equations that aren't necessarily factorable.
Now there are actually 4 strategies that we can use when solving quadratic equations. The first strategy is factoring, which we've already studied. We can use the different factoring strategies in the zero product property to help us solve equations that are quadratics. The second strategy, which this video is going to focus on, is the square root strategy. And then there are 2 more strategies that we'll study later on in this chapter called completing the square and quadratic formula. But this particular video is focusing on the square root strategy.
So to start learning about square roots, let's look at the following. So here we see that we have x squared is equal to 9. And most students are off the bat already able to tell me, well, x squared is equal to 9, and I know that one value that makes that true is x is equal to 3. And then at this point, I tell the students to think a little bit more outside the box. So yes, x equals 3 does work because 3 squared does in fact equal 9. But I remind them that there's actually another number that when squared is equal to 9. And after they think for a little bit, they remember that negative 3, so negative 3 times negative 3, so negative 3 squared, is also equal to 9. So we actually have two values for x here that work and make this equation true. So that's the first thing that we look at, is we think outside the box and we find two values for x that make that equation true. We then also talk about if we have the equation x squared equals 9 and we want to find the value for x, how on earth do I find x if I don't know what it is? And we talk about then two functions that undo each other, just like addition and subtraction undo each other, multiplication and division undo each other. We talk about how the squared function, which is what we see here, the squared function and the square root function undo each other. So then we talk about how if we had this in an equation, what we could really do to each side to get x alone is we would square root the x squared. And then we'll square root the other side, because whatever we do to one side, we have to do to the other. So we would square root the 9. So if we square root a squared, then the x is by itself. And if we square root 9 in our calculator, it will only tell us the single answer of 3. So what I tell students is we can use that square root function to help us find this first answer here of 3. And then we have to remember that the negative version of that could also be squared and equal 9. So we would write down the second answer as well. So we can use this square root function if we don't remember what number when squared would give us 9. And then remember we have to think outside the box and write down both solutions. So now let's look at some problems that are a little bit more complex. So all of these contain an x squared, and our goal is to find all of the possible solutions for x by using our knowledge of our square roots. So whenever we have a variable value, our goal is always to get the x value by itself. So here if I look at this first example, I notice that x is not by itself. So I want to start by moving the 40 because I want to get x by itself. So I would then have 5x squared is equal to 40. And then I need to still get x squared by itself, so I divide both sides by 5. So here I find x squared is equal to 8. Now, unlike the problem on the previous slide, I don't actually know what 1 squared equals 8. This isn't a nice number. So this is a situation where my square root function is really helpful. So I know that in order to undo a squared, I can utilize the square root function. And as I do that, if I square root 8 in my calculator, I'm going to round to 2 decimal places, but it tells me that the square root of 8 is about 2.83. That's about what it is. So what I'm going to do from here is I'm going to use that knowledge and say, well, I know that when squared, 2.83 will give me 8. And then I also know, thinking outside the box, that the other option is that x is equal to a negative 2.83. And that 1 squared will give me 8. So I can use that square root function to my advantage to help me find both of my possible solutions. Now if I look at the second example there, I can see that, again, I do not have anything with an x by itself. So I'm going to start off by adding 10 to each side. So I have negative 2x squared is equal to a negative 40. I then divide both sides by a negative 2, and I end up with x squared is equal to 20. And again, I have a situation where I'm not quite sure what 1 squared will give me 20. So again, I'm going to utilize the square root function to undo the square around the x and to figure out what 1 squared will give me 20. And if I square root 20 in my calculator, I find that rounded to 2 decimal places, it is about 4.47. So then from here, I can use that to my advantage and say, well, there are 2 options for x. One option is that x is 4.47. That 1 squared will give me 20. Or the other option is negative 4.47 when squared will also give me 20. All right, and finally, if I look at my third example down below, this one again, I notice that I do not have my x squared part by itself to start. So I need to subtract 30 from each side. So I have x squared is equal to a negative 20. And then again, do not know what 1 squared gives me a negative 20. So I take the square root of each. And when I take the square root of a negative 20 and put it into my calculator ends up telling me that I have an error. And if I start to think about this a little bit, I notice here that I have something when it's squared is giving me a negative number. And if I realistically think about that, something when squared, it will be the same number. So I'll either have a positive times a positive or a negative times a negative. And I know that when squared, a positive times a positive produces a positive, and a negative times a negative produces a positive. So essentially, we have an error here because nothing times itself will give us a negative number. So if you end up with something squared equals a negative and you try to square root the negative and you notice it's an error, what your calculator is really telling you is there is no solution here. There is no value for x that 1 squared will give you a negative 20. So be on the lookout for those no solution situations. So now that we've tackled some easier square root problems, let's look at things that are a little bit more complex. So if you look at the equation on the screen, what you're hopefully noticing is that our squared part is this entire piece in parentheses. And we talked in previous chapters about how this part really means x minus 4 times x minus 4. So we can't just like move that squared onto the x and the negative 4 on the inside because we know that this problem is a little bit deeper. So in order to start this problem, we're going to focus on getting this part that is squared by itself. Because essentially that part being squared is really messing with us right now. So if we can get this part that is squared by itself, hopefully we can undo that squared function and then be able to solve this problem a little bit further. So in order to get that part alone, we need to start by dividing each side by 6. So by dividing each side by 6, these 6's will cancel out, and then I'll have 54 divided by 6, which leaves me with a 9 on the right-hand side. So I divide both sides by 6, and I end up with x minus 4 quantity squared is equal to 9. Now let's think about this a little bit. When we're looking at this, we're noticing we have something, this part on the inside, something when squared is equal to 9. Well, I know that there are two items or two numbers that when squared equal 9. I know that 3 squared is equal to 9, and I know negative 3 squared is equal to 9. So really what I know here is that this inside could be equal to 3 or negative 3 because it's being squared ultimately. So this x minus 4 on the inside, if it equaled 3, it would then become 3 squared and it would equal 9. Or if the x minus 4 part equaled a negative 3, it would be a negative 3 squared is equal to 9. And that would equal 9 as well. So what we can do is we can start to brainstorm what would the inside of this need to equal in order for that equation to be true. Well, the inside of those parentheses need to equal a positive 3 or a negative 3 so that when it is squared, it equals 9. So now that we've kind of brainstormed, okay, x minus 4 could equal 3 or x minus 4 could equal a negative 3, now we can actually solve this mini equation here. So we just add 4 to each side, so we find x could equal 7. Or we add 4 to each side in the second equation, and we find a second answer of x is equal to 1. So here, by using our knowledge of the squared function and how square roots work, we were able to find two values for x that if you plug them back in, make the original equation true. Now if you're a little skeptical, we can actually check these answers by plugging them back in there and checking that they make the original equation true. So here we would take 6, we'd have 7 minus 4 quantity squared is equal to 54, and then we just use order of operations. Inside parentheses, 7 minus 4 is 3. So that's 3 squared, then still the times 6. Well, then we take the exponent, so that's 3 squared is 9. And that does in fact equal 54. We know 6 times 9 is 54. Then if we try the next one, we would take 6 and then we'd have 1 minus 4 squared. Again, we do the parentheses first, so we'd have 6 times negative 3 squared. We then do the exponent, so it would be 6 times 9, and we know that that does in fact equal 54. So again, we have a situation where if we plug those values in for x, they work in that original equation and make it true. So now let's try something slightly more complicating. Again, we want to get this parentheses squared piece by itself because that's the complicated part that I want to undo the squared around. So to start off this problem, I actually have a different first step. I first need to subtract my 1 over. Can't divide by 2 until that 1 is gone. So then I have equals 120. And then I divide both sides by 2, which leaves me with 3x minus 4 quantity squared is equal to 60. And this one is a little bit more difficult because I notice that I don't know what when squared is equal to 60. So I'm a little bit stumped here because I don't know what when squared is 60. So what I need to do is I need to utilize my knowledge of square roots to undo my squared. So I'm going to square root both sides to undo my squared, and then I'm going to think off to the side, what is the square root of 60? Well, if I square root 60 in my calculator, I find rounded to 2 decimal points that the square root of 60 is approximately 7.75. So I know that the two numbers that when squared give me 60 are going to be 7.75 or negative 7.75. Those are my two numbers that when squared will give me 60. So what I do with my inside piece here is I set my inside piece here of 3x minus 4, and I take that piece and I say, well, 3x minus 4, if it is squared, and I want it to equal 60, 3x minus 4 will either equal 7.75, because that when squared gives me 60, or 3x minus 4 will equal a negative 7.75, because that when squared will give me 60. So I start by thinking that through, okay, what when squared gives me 60? Well, 3x minus 4 could either equal either of one of those two options. Then from here we start to solve. So we add 4 to each side. So I have 3x is equal to 11.75. And then I divide both sides by 3. So if I take 11.75 divided by 3, I find that x is equal to approximately 3.92. So that's one possible value for x that will make that original equation true. Now if I take 7.75, the negative version, and I add 4 to it, I get 3x is equal to a negative 3.75. So notice this is a little bit different. Divide both sides by 3, and I find x is equal to a negative 1.25. So notice here that I do not have the same answer twice. Notice here that it's a little bit different. So we're brainstorming, okay, the inside needs to equal one of these two options in order to be squared and equal 60. We set them equal, we solve, and we found two values for x. We found x is equal to 3.92 and x is equal to a negative 1.25. So I want to add this sentence into your notes because on the previous slide we actually learned something very important. So this was where we got on the previous slide before we had to use the square root function. And here we noted that in order to figure out what 1 squared gives us 60, we had to square root both sides. And what we learned here is that anytime we square root something that is squared. Now here it says squared variable. It could also be squared variable in parentheses. It doesn't really matter. What matters here is that we're square rooting something that is squared. So it has this squared piece up here. We must include a positive and negative version of that. So that was why we had the 7.75 and the negative 7.75. Because there are actually two possible solutions that when squared give us the 60. So you need to remember that piece, that there are also always two answers that when squared give us this 60 over here. So if you square root anything that is squared, you will always have two possible answers. So make sure you don't miss those two possible answers.